Welcome to PhysioMEA, a novel, open-source platform designed to advance the analysis of multi-electrode array electrophysiological data. Our journey begins with the creation of a cardiac organoid. Here, you can see a spontaneously beating cardiac organoid. With every gentle pulse, electrical activity spreads through it. After recording the organoid's electrophysiological signals, we move forward to advanced signal processing with PhysioMEA, your gateway to deeper understanding and meaningful discovery. This is the PhysioMEA graphical user interface. Simple, intuitive, and powerful. First, load your data and assign a name to your analysis project. To plot data from all channels on the matrix of figures, which represents the MEA plate, adjust the time range. Next, select the channels with high signal-to-noise ratios through the easy-to-use graphical user interface or unselect those with a low SNR ratio. Here, you can see all 60 channels recorded from a spontaneously beating cardiac organoid. Define the desired sections of the signal for analysis, and save your project with just a few clicks. Now, the peak detection process. PhysioMEA's advanced algorithms filter the signal, detect the R, S, and T peaks, and automatically calculate key electrophysiological biomarkers, ensuring precision at every step. Here's the result: a filtered electrogram from a spontaneously beating cardiac organoid, with peaks clearly detected. PhysioMEA also generates advanced visualizations for each biomarker, including time series plots, bar graphs, scatter plots, and histograms, bringing clarity to complex data and insight to every detail. Next, PhysioMEA enables unique two-dimensional analyses of electrophysiological measurements. Through its advanced settings, you can visualize how each channel's signal evolves over time as a dynamic two-dimensional potential heatmap. Adjust and explore to achieve the perfect view. In addition, PhysioMEA provides a signal propagation heatmap, displayed over time, which quantifies the time required for each beat to propagate across the sample, thus revealing how the excitation wave travels across the cardiac organoid. And for the first time, PhysioMEA introduces two-dimensional biomarker analysis, displaying spatial and temporal changes in biomarkers, field potential duration, FPD, amplitude, AMP, slope, and peak-to-peak duration, PPD. These analyses can be easily saved using the PhysioMEA interface. For example, the potential, signal propagation, FPD, and AMP videos. But that's not all. For the first time in cardiac organoid research, PhysioMEA also offers beat rate variability, BRV, analysis, designed to uncover rhythmic patterns and physiological insights that were once beyond reach. Using the beat rate variability module, experimental categories are defined and experiment analysis projects are loaded for comparison. Each experiment analysis project section is attributed to its respective category, and the analysis runs through them automatically. Results include detailed comparisons of beat rate variability metrics between experimental conditions, presented in both a table and bar graphs. Time domain, frequency domain, and nonlinear beat rate variability measures can be explored, all clearly visualized within the platform, for each channel dataset loaded. In summary, PhysioMEA is an open-source, comprehensive platform that brings together advanced signal processing, two-dimensional analysis, and beat rate variability tools, empowering researchers worldwide to accelerate innovation, share discoveries, enhance data presentation, and advance the frontiers of cardiac electrophysiology. Join the PhysioMEA community today, accelerate your discoveries, and enhance how you present them.